Git, a distributed source control repository. I try to picture clusters of information as they move through the file system. Were the commit messages like history books? I kept dreaming of a repository I thought I'd never see. And then, one day, Git real.
You're watching Level 1 of Get Real. I'm Greg Pollock, and in this level, we're going to go over some of the real basics of using Git. So if you're already familiar with these basics, maybe you did try Git, feel free to skip over the video and go straight to the challenges. The first time I got a gig working with the web, it was pretty typical. So there I was, first day on the job, and I needed to edit a website. I was told to FTP the file down, make changes locally, and FTP them back up, which works fine until you find out there's somebody else who's also working on the project, and at times they may pull down the same file, make changes, and you both may try to upload and overwrite each other's changes, and it's just a big mess. This is where you might need a version control system. So what is a source control repository and what does it do for you? Well, the first thing it does is it deals with these sort of situations where you have two different people working on the same file and you both check in that same file. It will try to merge that file for you. The second and more important thing is that it works as a time capsule. So over time, as you make changes to files and you check them into your source control, it keeps a time log so that you have a complete history of all the files that have changed and even why they changed. You can see these are all the different versions in version control. Up until recently, most version control systems used a centralized repository. What this means is that you have multiple people, and when they make changes and they make commits and store that in the history, it's all going to one central repository, one server. Some version control systems, like Git, are distributed. This means that everybody has a complete copy of the repo. The nice thing about this is that you can make commits really quickly. You can work on it offline, and, well, everybody has a complete copy. That way, if one gets destroyed, well, everybody has a copy of the repo. Unlike working with a centralized repository, well, if you lose all your backups and the server goes down, well, you're kind of out of luck. So now you know what it means when we call Git a distributed version control system, or DVCS. Git was created by Linus Torvalds when he was working on the Linux operating system, and he lost access to the proprietary version control system he was using. He wanted to create something new, something that was fast, that's distributed, and was good with working with large code bases, well, like Linux. Most people work with Git on the command line, so in this course we're going to be teaching all of the command line tools. That being said, there are still a lot of graphical user interfaces that you can check out, and if you want to install Git or download some of those GUIs, you can go over to git-sem.com. Like most command line tools, Git comes with a help system, so if you ever get stuck, you can run git help. It'll give you a list of the commands. And then if you want to get more specific, you can type git help and then the command you need more information about, and it'll have pretty good documentation. Your first step when you install Git is to set some basic configuration. You're going to want to set your username, your user email, because, well, what good is filling a commit with awesome code if you can't take some credit for it, right? And we're going to run one last command to get some pretty colors on the output of our command line. So you've installed Git and you're ready to work on your first repository. Well, we're going to need a directory, so let's create a directory if we haven't. We're going to go into that directory. We can work on some files at this point, and when we're ready to start the repository, we simply type git init. This is going to create a local Git repo for us. It's not up on any server, it's just local. It's actually stored in that .git hidden directory. You're never going to need to go into that directory, just know that's where it's all stored. Let's start working with Git, and we're going to talk about our workflow before we get into the commands. So Jane, our user here, is going to create a README file. That README starts out as untracked. When we're ready to start tracking that file, we're first going to add it to a staging area. We're getting ready to take a snapshot. Then we're going to create our first commit. And a commit is basically like taking a snapshot of those files that we put on the stage. We then might work on our project more. Maybe we modify the README and add a license. We're going to add those files to the staging area and make another commit. So this is sort of the workflow for Git. You do a little bit of work, you stage it, you make a commit. Let's jump into the commands. One of the most important commands with Git is the git status command. This is going to tell you what has changed since your last commit. So if we run git status, and we don't have any commits yet, it's going to tell us that we have one newly created file that's not being tracked. To start tracking it, we first need to add it to the staging area. We do that using the git add command, doing git add readme. And if we do another git status at this point, we're going to see that this file is now ready to be committed. It's currently staged. Now we're ready to make our first commit. We do this by running git commit -m, and then we describe what these changes do. So in this case, create a readme. When we run that command, this creates our first commit, which takes a snapshot of the stage, and that gets added to our timeline. If we run git status at this point, we can see that there's nothing else to commit. There's no other changes or files that we've modified that we haven't committed yet. Git status also tells us that we are on branch master. All you have to understand here is that we've got one main timeline at this point, and we're going to call it master. We'll get more into branches on level 3. Now we're going to actually do some work on some files. We're going to modify the readme and add a license. Now if we run git status, we're going to see that our tracked file, readme, has been modified. It's keeping an eye on that file, so it knows it's been modified. And we have a new file we need to add that's not tracked, called license. We want to commit both these files, so we need to add them both to the staging area. We can do this by simply doing git add and listing both of the files, or we can do git add -- all, which will add all new modified or deleted files to our stage. Now if we run git status again, we're going to see we have two files that are ready to be committed. So from here, we need to go back and do another commit. So here you can see we do git commit -m. Now we can commit our changes off of the stage and specify what the commit does, in this case add license and finish readme. This is going to create a snapshot and add a commit to the top of our timeline. Now we have two commits, but how do we list from the command line what those are? How do we look at the history? That's where the git log command comes in. So if we run it here, we can see we have our two commits listing the author, the date, and our commit message. As you can imagine, when you're working on a larger project, commit messages are very, very important. And so you want to try to be as descriptive as possible as to what they do. Plus, it's good to keep in the present tense, not the past tense. I could have said created a readme file. It might be tempting to do that. But what you want to do is think about what the commit does. In this case, create a readme. Now we're going to go over some different ways to use the add command. As you saw, you can just simply list out files. You can use git add -- all. Git add star.txt will add all the text files in the current directory. If we want, we can specify a directory like docs/star.txt. We can also just add all the files in a specific directory and all of its subdirectories by doing git add docs. And lastly, if you put quotes around star.txt, it's going to go add all the text files in the entire project. You've reached the end of level 1. It's time to start running your own commands and get real.